So today we're going to talk about the dummy variable. So this is the chapter that is almost the last chapter in our syllabus. What we want to explain that why do we need a dummy variable in our models, and how do you determine the use of a dummy variable? That is our target in this lecture. So let me open up my board. So as we said, our objective is a dummy variable. That is our chapter. And a lot of time we also say dummy variable looks like a binary variables. Binary variables in terms of our logic is an yes and no variable. Something is there, something is not. Now you might think about it. What does it mean? The answer is very simple. That when we are dealing with data, remember we have data, and we say data can be of different types. Some data are measurable, quantifiable. In other words, we can quantify them. Some data are qualitative data, not quantified. So that is where we start using dummy variables. So what is a qualitative data? Think about example of education. It's a good way of understanding qualitative data. If I say class 1, class 2, class 3, up to class 12, for example, there is a definite order between them. But the difference between class 1 and class 2, class 2 and class 3, class 3 and class 4, these are unknown. So it's not like the difference between is 1. Answer is there is different quality. Class 1 represent one quality, class 2 represent another quality. So these are qualitative variables, but these are ordered quality variables. We realize these can be ordered properly. We know which one is bigger, which one is smaller. We know the knowledge of class 12 is bigger than the knowledge of class 10. So in a way, we know this is ordered, but it's still a quality, not the quantity. Another way of looking at dummy variable, let's say we look at religion in our data. So some people are Muslims, some people are Hindu. So think about it. These are different religions, Buddhist and Christian. Question is, these are also represent certain quality of mindset and attitude, values among different individuals. And we cannot say which one is 1 and which one is 2. In other words, it is not even ordered. So there are two types of qualitative variables. Some qualitative variables are ordered qualitative variables. Some variables are not ordered, but still quality. Each religion people represent a set of values, and that may explain his or her behavior in the real life. So if I want to use religion as an explanatory power for certain human behavior, then I need to use dummy variable. But this dummy variable will be pure binary. Similar, another way of example of the binary religion is also gender. So gender is another example where we know that there are male and there are female. But we don't know which one is bigger, which one is smaller. There is no order. But what we know that male represents certain set of attitude and values. Female represents a different set of attitude and values. And because of their gender, their behavior in certain aspects are completely different. In order to capture these type of variables in a model, to explain why, remember our objective of the model is we want to say y is a function of x2, x3, and xk of the many variables we can think about it. And one of the variables may be gender. Gender may explain, for example, purchasing behavior of a consumer. So the male purchasing behavior versus a female purchasing behavior completely different. Similarly, in terms of, so that could be one. The religion could also be explaining the purchasing behavior of individuals. So yes, if you are a Muslim, you expect certain products, demand for certain products. If you are non-Muslim, you have a completely different set of demand for different products, which means my demand for a product is actually explained by many other factors, and some of these factors may not be quantified. And that is when we start using dummy. So that is what the dummy variable is supposed to be there in our models. In our model, we use dummy variables whenever we come across with this kind of a problem. Okay? So now let me go into this. And so the question that we should realize that dummy variables are useful for uh, for explaining certain phenomena in consumer behavior or in any human. So when you have these and we want to include them in a model, how do I do it? So think of an example. Let's start with another example. So this is an example of explaining, for example, in this case, we want to look at income. It's very common. And we know that income, and in many cases, there is a idea of discrimination, for example, gender-based discrimination. What we mean that even if I have the same education, even if I have the same experience, it may happen because of gender. Some gender, for example, male, may have a higher salary than female. Now, if that happens, that is when we say there is discrimination because everything else is same, but only because of gender there has been a bias and male earn more than female. That's how gender discrimination is all about. Not that male earn more. Answer is not only male earn more, but everything else is equal and still male earn more. So that means I'm saying that gender explaining this, and there is a bias in the salary market always. And a lot of times these are discussed in the social literature. That is there a bias in terms of opportunities for employment, in terms of getting a job, in terms of income between gender or between religion, or for many other reasons, whatever. So you think about it between different races in many cases. So this is when we start using a dummy within our model. So if I now look into a data set, I'm just giving an example. So let's look into this. Let's imagine that this is the income on this axis y, which is the income, and this is the education. And if we know that if education is higher, we expect income to be higher. Or if we look into, we can say education is a dummy, in that is a quantifiable but ordered variable. Let's say experience is a better variable. So experience in years. So if I have more experiences, you expect more salary. So if you look into the collection of the data, you may find out that this is the data that we see. It is also possible that we look into the data and we see another set of, which is this one. So I'm coloring it differently so that we see the two data sets. And let's say these are male data and the red one are female. Means we are looking at income. Everything is same. So if I now look into this is how it looks like. If I run one model for male, this will be model for male. And if I run another model for female, this will be model for female. So in other words, we can see there is a difference between male and female. And that could be then labeled as the existence of discrimination in the market. And that's when people say, is there a discrimination between male and female in the job market? Answer is we need to make sure that every other things are equal. And that's when we use regression. So how do I model? So this is difference is known as the difference in the intercept. So remember, the difference could be only in the intercept. The intercept could be a difference, and that intercept is actually explaining the difference between male and female. And we would like to test whether there is a discrimination in the job. If I want to look into this model, theoretically, this model would be look like A plus, let's say A1 plus B1 experience, and this could be look like A2 plus B1. We realize that the slope is exactly the same. So what is the difference? Difference is in the intercept. So we actually could do two regression models. One is you regress male income as a function of, so let's say this is alpha male plus beta experience plus absolute. This is the first model for the male, and female model will be YF equal to alpha F plus beta experience plus. We could theoretically estimate two different models. It may happen, you may not have enough data to run two models. So the question is that how do I combine these two models into one and estimate one equation rather than two? And that is when dummy variables becomes important. So what is the strategy? Now realize that theoretically, if alpha m is statistically different than alpha f, and alpha m is bigger than alpha f at the population, in this case we can say that there is a starting point bias in the solution, initial income bias in the solution, in the job market because of gender. That's how we establish discrimination of gender. So having said this, let's say if we can introduce a dummy variable instead of two regression functions, we want to establish one regression function. How do we do it? Answer is, let's imagine y is an income, and we say it is alpha plus beta x. Remember, x is experience, plus let's say gamma g or gender plus f, and we say g is equal to 1 when it is male, and g is equal to 0 when it is female. So realize this becomes a binary variable. So realize what happens. We have a g, which is the gender. We said it is 1 as a male, and 1 is 0, it is female. So you think about it. When it is a male, what is the equation with? So for male, equation is y equal to alpha plus beta x plus gamma plus, this is the male equation. And what is the female equation? Female equals to alpha plus beta x plus x. So you realize what happens. So I'm putting g equal to 1, and that becomes gamma. G equal to 0, this is 1. So we have this. So we have male equation, female separated, but we estimated in one equation. And how do I know there is a discrimination? As long as gamma is statistically significant. So if we go to it, and if the null hypothesis is gamma equal to 0, that means there is no discrimination. If gamma is not equal to 0, that means there is a discrimination in the job market. So we can establish discrimination in the job market by running this model. And this is a dummy variable. Instead of G, if I use the book's notation, we say, no, this is a dummy variable, so we put a notation called D. So we say this is D rather than G. Nothing wrong with that definition. Now, you realize that there are two categories, but I'm using only one dummy variable. Means dummy variable will take either one or zero. So that's how we get the intercept based on. But however, if there is a similar example, can we say there is a religion-based discrimination in the job? Example. Which means I have, and let's say that we have religion R is divided into Muslim, Hindu, and let's say others. So we're basically looking at three different types of majority Muslim in Bangladesh, Hindu, and then others. Everybody else. Now the question is, if dummy variable has only 1 and 0, it cannot have three variables. It cannot have three numbers to be present. So this is when we need to think about it. That how do I create the dummy? The answer is you create two dummies. One dummy for Muslim. So That's one dummy. And second dummy for Hindu. So we have two dummy. So what happens if a Muslim, first dummy D1, let's now look into this differently. Let's think about D1. One is Muslim and zero is non-Muslim. Sorry. No. And D2 is another dummy, whereas one is Hindu and zero is non-Hindu. So realize that because dummy variable has only 1 and 0, if there are more than 2, then I need to think about a second dummy to bring. So what happens if I look at my model? Y is equal to, you can look into this model and look at this perfect. Imagine this D2 and D3. They started with D2 because they went to D2, beta 2 and beta 3. That's how they're looking. So let's say this is Muslim, this is 1, but not a Hindu, so this is 0. So Muslim's coefficient becomes beta 1 plus beta 2. This is for the Muslim. Why? Because you look at this. Beta 1 is the constant, and then for Muslim it is beta 1 plus beta 2. So this is for Muslim. What is for Hindu? For Hindu, this will be, so let me erase this one. For Hindu, this is D1 and this is 0. So for Hindu, it will be beta 1 plus beta 3. Now what other religion? Other religion means, theoretically, neither Muslim nor Hindu, so both of them are. So the coefficient, the income is beta 1. So you realize that this is for Hindu. I'm just giving an example, and this is for others. So what happens? We now realize that the intercept for Muslim, so this is how it looks like. Imagine that Muslim has the highest income. So this will be Muslim, this will be Hindu, and let's say this is the other religion. So this is actually beta 1. This part is beta 1 plus beta 3, and this part is beta 1 plus beta 2. So realize that we have 3 intercepts. And if beta 2 is significant, that means there is a discrimination in favor of the Muslim if beta 2 is positive. If it is negative, it means there is a discrimination against Muslim. We don't know which kind of discrimination. But in order to define this, we think about it. I said, okay, let's test this. So if I run this regression model and find beta 1 is significant, beta 2 is significant, that means, and it is positive, that means the job market in this example, if I'm assuming this to be income, then I'm saying the job market income of the Muslim is higher than others. Others means, remember, others is beta 1. If beta 3 is significant, then we are saying income of the Hindu is higher than others. But the question is whether beta 2 is bigger than beta 3. If beta 2 is bigger than beta 3, that basically means there is also a discrimination between Muslims and Hindus. I'm just giving you the idea that how can you can use these, and these are the basic questions that often appears in the literature, and people would like to know the answer. So there's one issue is which is known as intercept. The second issue is called slope dummy. What is a slope dummy? Not that there is an intercept differences. It's like there is a difference in the slope. Think about this one. This is the male and this is the female. So what may happen that with female income, imagine this is income. Imagine this is experience. And what we are saying that up to certain experience, let's say this is equal to 5. To give you an example, up to 5, it is possible that male income, this is for male, this is for female. Female income is lower than male income. After this, female income is higher. So why? Because the increment of salary between male and female over 2 years. maybe for a different reason. So you might say not only that there is a, so this is one example. Another way of example is this one, which would be only slope down. So remember, the first example that I was giving is both there is a change in the slope as well as in the intercept. In the second example, there is only intercept. On the slope, there's only slope changes. So it might happen there's only slope changes, or you might say in a different way. Let me explain this a little bit differently, so that because I have already complicated this for you. So let's go back and draw this differently. Let's say only slope differences, which means this is income, this is experience, this is the, so for example, this is male, this is female. What do we see? That starting salary is same, but over time, female gets higher salary than male. That's a reverse discrimination. It could be the other way. That male may have got higher salary, even though the starting is same, but the male get a higher salary over time than female. So remember, the discrimination is not only in the salary they get, but also in the rate of increase. That could be discrimination. How do I establish this? And this is when the slope dummy becomes important. So how do I create a slope dummy? So the creation of a slope dummy, if you want to define it, is this one. So a we have a model. How do I create a slope dummy? The answer of slope dummy is very simple. We have same here alpha. We can up for now. Let us not worry about this. So see what happens. We have y equal to alpha 1 plus beta 1 x plus beta 2 dx plus epsilon. And d is equal to 1 if it is male, and d is equal to 0 if it is female. So what happens when it is female? So let's say, think about male first. If it is male, d equal to 1. So this will be beta 1 plus beta 2. So what is the slope? For male, the slope would be beta 1 plus beta. For female, this is for male. And for female, because d is 0, so this 0, this whole thing becomes 0. So this will be only beta. So this will be for the female. So we can see that if beta 2 is statistically significant, that means there is a discrimination. For or against male depends on whether beta 2 is positive or negative. So you can use the slope dummy to understand whether there is a discrimination. I'm just giving a discrimination, but it could be any productivity differences, anything that you want to discuss, any behavior you want to explain. If there are qualitative issues involved, then we do this. So, and you could actually, in this example, the book has given both slope and intercept. So how do I include both slope and intercept them? We said alpha 1 plus alpha 2 d1, and this could be again male and female. I'm just giving an example. This also male and female. So we have both slope and intercept differences. What is the slope and intercept differences? If we look into this as an example, so see what happens. In this case, when I have both intercept and slope dummy, for male, if it is male, remember this is d. So let me eliminate this equation so that we can draw it right from the book. So if this is d equal to 1, now that means for male, the slope is, the intercept is alpha 1 plus alpha 2. Remember, this is at the population. And for the slope is beta 1 plus beta 2. So we have both slope and intercept. This is for male. For female, this will be only alpha 1 because d will be 0. And this will be 0. So it will be alpha 1 and this will be beta 1. So realize that we have both slope and intercept. Both of them are different. So if it's a look, if alpha 2 is statistically Equal to 0, that means there is no difference. If not equal to 0, that means there is this discrimination at the starting point, which means 0. Remember, experience 0 means starting salary. So there could be discrimination both at the starting salary as well in the increment in the salary. So we would like to cast this. And these are normally casted using this kind of equation. In this book, there is another example, which may be a period. We want to study whether during a government, particular government, things have changed. So if I have a period, for example, 1991 to 96, let's say this was a BNP period, so they have a different policy. Then we have 96 to 2001, we have another government, which is Aum League government. And then we have 2001 to 2006, we have another BNP government. And then we have now Aum League. So we would like to know whether there has been some behavior change somewhere, let's say savings in this example, because of the regimes, because each government produces different policies. So we would like to know, is there a consequence of government policy of a particular regime on this? Or we can say whether 2006 to 2008, which is, for example, the military government, whether that government has changed anything. On those issues, we actually use dummy values. So they have used a dummy for 1982, right? And they have said another period of data is without the dummy. So government changes. It takes an example whether Ukraine war has created a change. How to establish? So we put our data, divide our data into two periods. Before, this is before, and this is after. So after is one, before is zero. So you can use a dummy to explain whether Ukraine war, for example, has statistically created differences in the economic growth rate of countries or inflation model. So one thing is observing from the state data, another one whether it is true at the population. And that is one we use dummy variables. So I think it is clear that how to use dummy variables. So it could be gender, one example of using dummy variables. It could be race. Many of the American data have race, black, white, and others. It could be religion. It could be education. If it is education, we need multiple dummies. If it is religion, we need multiple dummies. How many multiple dummies? The formula is very simple. If we have two groups classification, we need one dummy. If you have a three groups classification, you need two dummies. And if you have 10 groups classification, you need 9 dummies. So the idea is very simple. If there are m groups, you need m minus 1 dummy. In other words, dummy variable must be one less. If there are two genders, male and female, you need one dummy. If there are three genders, male, female, and others, then you need two dummies. If there are four religions, you need three dummies. So idea is, and if it doesn't happen, then statistically what happens is known as dummy variable trap. So we know it's known as dummy variable trap. And what is a dummy variable trap? The answer is in your x variable, x prime x, remember, inverse. That inversion will not exist because of singularity of the matrix x prime x. Now, if you since I know you are not familiar with all the matrix notations, so I'm not going into that, but you realize the thumb is very simple. If you have two classifications, you need one dummy. If three classifications, you need one less dummy. That is the whole idea, and that will allow you to avoid the dummy variable trap. Otherwise, your model will show a dummy variable trap and you will not be able to estimate it. So that is more or less the issue of dummy variable in the model. And we use it in many cases because many of the social behavior are influenced by factors like education, factors like urban, rural. So if you're a rural person versus you're an urban person, your behavior is different. If you are coming from a pious family religiously, then others, your behavior is different. If you are male versus female, your behavior is different. If you are white versus black, your behavior is different. If you're a smoker versus non-smoker, your behavior is different. There are many of these social issues which are not quantifiable but qualitative. There is a difference. Similarly, if there is a regime change, that means between certain years are difficult years in an economy than others. Is this caused by the difficult period? That means you create it up. So this is how we do dummy variables in our models, and that's very common. And way we do it, you remember this example is come. It idea is very simple that if you use a dummy variable, and whether you say whether dummy variable has been able to create a better explanation of your model. So you might find out by introducing dummy variable, the R square will go up significantly. And one of the way to test model with and without noun variable is the chow test. Remember in the last class we talked about chow test. We said if there are two models, and if I want to say whether the model 1 versus model 2, the model 2 has been able to do better, then if you remember the R square, this is R square 1 and this is R square 2. So you'll be able to use the chow test to find out whether the model 2 has been a better model than better. So we would be able to explain that whether certain social aspect has been able to change human behavior. So in a way, I think dummy variable is important for all modulars, particularly in social science and businesses, because human behavior are affected by many things. Season is another example. So seasonality, the demand for a product, different seasons completely different. So maybe the demand is here, the demand is there. Maybe supply would be different between the seasons. This is the supply during the harvest season. Whereas if there is non-harvest season, this will be the supply. And you know that between harvest season and non-harvest season, the demand is same, then we say, okay, I can see why prices are different because of the supply. Similarly, because of the demand, the demand for a Ramadan month versus non-Ramadan month, very common, is significantly different. And because of this, during Ramadan, we know in Bangladesh, this is the demand, normal demand. But in Ramadan, the demand may go up for certain products. And that is why prices are expected to go up unless there is a change in supply. So I'm just giving an idea that, okay, in those explanations, we need dummy variable. Having said all of that, I think the most important part of the dummy variable is to recognize, number one, is that it actually tries to explain the quality. Now, it explains the quality when quality cannot be quantified. So, for example, somebody has is male and female. I don't know what is the quantity. So we say this is one and this is two. We say that it means we're saying all male are same and all female are same. Now this may not be true, which means dummy variable, even though it differentiates between male and female, but dummy variable is not differentiating between two males. Because then we need another dummy, maybe two males. One is urban and one is rural. And that dummy will explain male urban, male rural, female urban, female rural. Different will be the behavior will be different. So we need to combine different types of dummy variable. And I want you to read this particular chapter because the chapter explains this and said, okay, how do we actually incorporate dummy variables in our model? So whenever you said y is a function of x2, x3, and many variables, xk, and some of the variables are education, some of the variables are religion, season, gender, division in Bangladesh, or districts. Some people in a district behavior may be different. People from different districts may have a different behavior in certain aspects. All these are captured by dummy variables. So dummy variables differentiate between each classes. As long as classes are distinct and we can identify them properly, we can use dummy variables to do this. There's another way of using dummy variables, which is more complex than this one. which is like a splitting human behavior. So, for example, what happened? This is a good example. This called spline model, where we know that there is a triggering. What is the triggering? That until the income, or in this case, sales of a company is this, these are the small companies versus these are the large companies. So there may be a difference between small companies and large companies. Now, if I define the small and large between a dummy, 1 and 0, that's perfect. But that will only tell you this type of model. Either this is, maybe this is small and this is large. Maybe this is small and this is large. Something like this. But what happens is that there is a triggering mechanism that if sales goes up beyond certain limit, companies change their behavior. So that triggering X star needs to be identified. And that's when we also use dummy and we create this modeling technique where we said, okay, what we define, we said y is equal to alpha plus beta x minus x star. I'm giving an example. X minus x star is my new dummy. So we say into, so this is my dummy. So we say there is a dummy. If this is positive, the dummy variable will have 1. If this is negative, dummy variable will have a 0. Which means for a positive number, this will have different value. For negative number, this will have different. So we change this between positive number and negative number. So in other words, we say if x minus x prime, let me show it in the book. This is a spline function. It's a known as spline function. So this is what happens. We say, look, if x is bigger than x star, we say it is 1. If x is less than x star, we say it is 2. So this is how the modeling is done. So what they created, they said, look, the slope is going to change because this is the slope. Slope is going to change if we have d is equal to 1 versus d equal to 0. Because remember, this is what will happen. This will become a constant, but this one remain x1. So remember, the slope will become beta 1 plus beta 2 if this is 4. If this is 0, the slope is beta 1. So 2 slope. Slope is beta 1. But if it is positive, this will be the slope. So this slope is beta 1 plus beta 2, and this slope is beta 1. So remember, slopes are different. So how did I introduce it? We introduce this x minus x star. And x star is a value threshold number which triggers a change. Now we can statistically estimate x. And statistically estimate x star is also using the chow, which means I use different values of x star to find out when the significance is much better. That's when we design. I'm not going into that for now, but I'm just giving you that how we use dummy variables anymore. So when we said what are the y is a function of x, remember our classes, we talked about y is a function of x. Axes, different axes. There may be some axes which are qualitative, and we need to use dummy variables in order to estimate the impact of these qualities. So that is what all about dummy variables, and I hope you will be able to use some of them in your assignment. Thank you.